All right, here we go. The first type of sequences that we're going to look at will be called arithmetic sequences. We'll get into what characterizes a sequence as arithmetic in just a minute or two. But first, I want you to look at the following sequence of numbers: 2, 5, 8, 11. Pattern recognition is a big part of what we're doing here in sequences. That's how this really translates to a younger audience, and I'll mention that a couple of times as we go through it. For you, we can study it at a little bit higher level, but the first thing I want to know is 2, 5, 8, 11, what would be next? What's the next term in that sequence? Following that pattern, what would be next? Laura, Katrina, 14. All right. And how you got that was by looking at these numbers. You could tell me if I'm wrong and saying, well, from 2 to 5, you added 3. And then from 5 to 8, you added 3. And from 8 to 11, you added 3. So the pattern here is just to add 3 each time. So the next term is going to be 14. That's exactly right. That idea that we add 3 each time, what we're seeing there between those numbers, we're going to refer to as the common difference. The difference between the numbers is the same each time. The difference between the numbers is 3 every time. So there is a common difference. That is what lets us know that we have an arithmetic sequence. When we see a common difference, we know we have an arithmetic sequence. Now, the next question down at the bottom there, I don't need an answer from you just yet. We're going to use that question to sort of spur us forward. What is the 20th term? And one approach you could take for finding the 20th term would be the brute force approach, and that's just listing them out until you get there. 14 is going to be next. 17 is going to be after that. 20 is going to be after that. Yeah, I don't want to do that all the 20th term. There's got to be a better way, and sure enough, there is. What we are going to do is find a formula that will help us find any term we want. Something that's going to be a part of our study of sequences is finding a formula for the nth term, where the n could be anything we want. The 20th term, the 50th term, the 173rd term, we can find a formula for any that gives us any term we want. Here's how we're going to do that. We're going to ask ourselves, okay, where does this sequence start? This particular sequence starts at the number 2. So, okay, that's going to be an important thing here. We need to know where we're going to start before we go forward. So that's going to be our starting point. And we're going to call that A. First letter of the alphabet, first number in our sequence, we'll call that A. Our common difference is going to be really important for us when we're building our formula for the nth term. We're going to call that D. So we have our starting point A, we have our common difference D, and now we're going to build this formula. And my question to you is, when we wanted to get to 11 here, we would call that the 4th term of the sequence. How many common differences did we have to do to get there? How many jumps did we have to do to get to the 11th, to the 4th term? If I want to get to the 4th term, how many jumps do I have to make? Exactly right, Laura. I have to make 1, 2, 3 jumps. And I can see Joanne has a formula there for the 20th term. She has 19 in there for the 20th term. We've got to do 19 jumps. And that's right, Katrina. To get to the 4th term, we need 3 jumps. So if we wanted to get to, say, the 40th term, how many jumps? If we wanted to get to the 40th term, how many jumps would we have to make? All right, Joanne, Laura, Kate, perfect, 39, very good. All right, now let's take everything we've been talking about and build our formula here. The way our formula is going to look is going to be n, meaning the nth term. I'm going to use different color. N, meaning our nth term, is going to be A, which is the starting point, plus however many jumps we need to make. And for right now, I'm going to write that as n minus 1, but I'm going to talk about it. And we're going to multiply that times our common difference. Let's talk about this general formula for an arithmetic sequence. So an arithmetic sequence, when we write the formula for the nth term, it's going to look like this, but we're going to be able to put a little bit more information in there. What we're saying is, here's where your formula starts, or excuse me, here's where your sequence starts. This is your common difference. And if you're trying to get to the nth term, you're going to have to make n minus 1 jumps. That's how many times we're going to have to do the common difference. That's how many times we're going to multiply by the common difference in order to get to our nth term. Just to sort of put a little more context on this, if we want the 20th term, we need to do 19 jumps. And so in this, we want n to equal 20, because when we plug that 20 in here, it's going to be 20 minus 1. That's where our 19 is going to come from. So our general formula for an arithmetic sequence is going to look like this right here. And then for this particular arithmetic sequence, we know what A is and we know what D is. We're going to be able to plug in for those, so we can do that. So we're going to say n equals the first term, which is 2, plus n minus 1 multiplied by the common difference, which is 3. If I want the 20th term, then I just need to plug in 20 and say, all right, the 20th term is going to be 2 plus 20 minus 1 times 3, which will be 2 plus 19 times 3, which is exactly what Joanne had for us a little while ago. 19 times 3, let's see, 19 times 3, that's 57. So here I have 2 plus 57. So the 20th term is going to be 59. Finding the 20th term is a great thing, but what we're really going to be focused on eventually is finding the formula for the nth term for any arithmetic sequence. Our basic structure is going to look like this. And we're going to plug in for A because we know what it is. We're going to plug in for D because we know what it is. Any questions on anything we talked about there before I have you try something? All right. Relatively straightforward. I want you to find the next term of that sequence. I'll make a poll for this one. What would the next term of that sequence be? A little bit of a, just to make sure we've got our feet on the ground with arithmetic sequences, a little bit of vocabulary involved in this one. So all this is asking for is what would come next. We'll go another 10 seconds on this one and then talk about it. All right, let's see how we did. Not unanimous, but strong agreement. There's a mistake here that's understandable for sure. The idea here is we are looking for the next term. So we want to know what would be the next number over here. Finding the common difference is an important part of that, but our answer for what's the next term is what would be the next number in the sequence. Our common difference we can see as we make a jump, we go from 4 to 11, so we added 7, 11 to 18, so we added 7. So to get to the next one, we're going to add 7, and the next term is going to be 25. It's an arithmetic sequence because it changes. We either add or subtract to get to the next number. The same thing every single time makes it an arithmetic sequence, and we can find the next term. Where we're building toward is find the formula for the nth term of the following sequence. Once we have evaluated the fact that, okay, I can tell this is an arithmetic sequence, I know my general format is going to be n minus 1 times d. So what I want to do is we're not going to do a poll. I'm just going to give you a minute to try to write the formula for the nth term, and then we'll do it together, and you'll have a chance to ask any questions that you want to. So in this particular case, we can see that A, the starting point, is 4. Outstanding, Laura. And then our common difference is positive 7. So we know that A is 4 and D is 7. Now we're going to write our formula for the nth term. And careful, Joanne, you don't have a plus sign in there. And I'll talk about that in just a minute. So our nth term here is going to be A, our first number, plus n minus 1 times D, our common difference. So here's the formula for the nth term. I'm going to do a little bit of a discussion here about writing these down. You may remember back when you studied lines in an algebra class, somewhere along the line, if you were to write an equation of a line that was y equals mx plus b, you would plug in for the slope and you would plug in for the y-intercept, and you would have something like y equals 3x plus 2. Notice, you wrote the equation of the line, the y and the x were still in there. Those variables stayed. That's what gave us the relationship between the two. I'm not going to ask you to do that here, but similar to that, when you write the formula for a sequence, the n stays, the n minus 1 stays. The only things that we're going to plug numbers in for are A and D. The other stuff sticks around. The n and the n minus 1 are going to be a part of our answer. So we're not going to write this in such a way that has that doesn't have any variables at all. We want it to have variables. We need it to have variables. We need it to have variables because if we want to define, say, the 33rd term, we want to be able to plug 33 in for n so that we can find the 33rd term. And then that would be 4 plus 32 times 7, which would be 4 plus 32 times 7 is 224. So the 33rd term of this would be 228 if we were asked for it. But when we finish, we need to have n and n minus 1 in there. I want to talk about this a little bit because if we were in a pencil and paper setting, I'd be able to look at what you wrote down and say, yeah, you got it right. You're going to be typing this into a quiz on Canvas or an exam on Canvas. And Canvas is going to be very specific. What we're going to do here is your instructions will tell you this, that we're going to have n equals 4 plus parentheses n minus 1 asterisk we'll use for multiplication times d. That said, I can be, as much as Canvas might not be, I can be forgiving. If you say, just stuck the 7 out there because that means multiplication and you didn't use the asterisk, it's okay. Canvas might count it as wrong. You send me an email and say, I think I've got mine right here. Is that okay? If you put parentheses around the 7 and Canvas doesn't like it, I tried to put different variations of the correct answer in there so that Canvas would be okay with it. But if you type one that that is along these lines, but Canvas doesn't like it, send me an email and I'll go take a look. So don't panic. Just send me an email and say, hey, I think my formula for that sequence is correct, and I'll go look at it. So don't panic, don't get mad, none of that. I will be fairly forgiving. What I mean by that is, and I know it was just a typo, and I'm not picking on you at all, Joanne, I'm just using that as an example. If you put into Canvas 4, n minus 1, 7, there's no adding in there anywhere. There's no addition symbol. That I can't give you credit for. Something I don't want you to do here that sometimes students have been trained to do is simplify as much as possible. What I mean by that is when you've got this formula right here and you go, well, I'm going to go ahead and distribute the 7 and call this 4 plus 7n minus 1. Then I have like terms here. So that's going to be 7n plus 3. It's not technically wrong, but this way allows us to see what A is and see what the common difference is. So instead of simplifying it to 7n plus 3, I do want you to leave it in this format. Sometimes I've had students put the 7 on this side, so it's 4 plus 7 times n minus 1. That's okay. That's fine. You get credit for that one. But try to mimic this format as much as you can. Any questions on finding the formula for the nth term for an arithmetic sequence? Very good. Geometric sequence. How to tell if it's a geometric sequence? Well, with an arithmetic sequence, we're either going to add or subtract the same number every time. For a geometric sequence, we're either going to multiply or divide by the same number each time. So my first question to you is, what's the next term in that sequence? 3, 6, 12, 24. And I don't know that you would have elementary age kids write the formula for the nth term. I think for them, pattern recognition is kind of what sequences are really valuable for. 48, Laura, Joanne. All right, let's see. So that's times 2, times 2, times 2. So we'll multiply by 2 again, and sure enough, we'll get 48 for the next term in that sequence. We're multiplying by 2 every time to get to the next one. What's the 10th term? Well, we could, 48 times 2 is 96, times 2 is whatever it is, times 2 is whatever that is. But just like we did with arithmetic, we're going to look for a formula for the nth term here. And our basic formula, oh, I need to mention this. We're not going to call this a common difference because there isn't a difference between the numbers. Instead, we're going to call this, when we have a geometric sequence, we're going to call this the common ratio. There's a common ratio between the numbers. If you made a ratio of 6 and 3, you get the same thing as when you do 12 and 6, which you do the same thing as you do 12 and 24. There's a common ratio between these numbers. And we're going to use R to represent that common ratio. A is still going to be our starting point, and our formula for the nth term of a geometric sequence will be the nth term will be A multiplied by R raised to the n minus 1 power. My guess is with the arithmetic sequences, you won't have that much trouble writing them down when you type them into Canvas. These are tougher to type into Canvas. Instead of, you can't really do an exponent in Canvas. So instead, what you'll use to indicate an exponent is a caret. It's the shift 6. So shift 6 gives you that, and that tells you to go up to the exponent. So this, a little clumsy to type, but it gets easier the more you do it. Starting number multiplied by, we'll use an asterisk for that, the common ratio raised to the n minus 1 power. One thing that I'm not necessarily going to be sticky on, but I should be, is these parentheses here. Technically, if you were to write it this way, order of operations would tell us that, okay, we're going to raise it to that power, then we're going to multiply by A, and then we're going to subtract 1. because please excuse my dear Aunt Sally, we do exponents, then multiplying, then subtraction is last. That's not what we're trying to do here. What we're trying to do here is we want to raise it to the n minus 1 power. And so that's why these parentheses here are important. If we're looking for the 10th term, we want to do the common ratio 9 times. So we'll do 10 minus 1. We're going to raise it to the 9th power. And that's why those parentheses are important. I will be forgiving on a quiz or an exam, but please try to remember that those parentheses do play a role. They are important for us. Oh yeah, at the bottom we're asked for the 10th term down here. Let's find this common ratio. So our common ratio is going to be the nth term will be a, the starting point of 3, multiplied by r, our common ratio, which is 2, raised to the n minus 1 power. So this is what our formula for the nth term would look like. 3 times 2 raised to the n minus 1 power. Now, if I want to find the 10th term, I would just do, well, the 10th term is going to be 3 times 2 raised to the 10 minus 1 power. So that's 3 times 2 raised to the 9th. And keep in mind what we're doing here is we're saying we're starting at the number 3, and we're going to do this jump where we multiply by 2. We're going to do that 9 times. That's what this formula tells us to do. And so 2 raised to the 9th, oops, wrong button, give me just a minute. 2 raised to the 9th is 512. So you have 3 times 512, or 1,536. And if you listed those out to the 10th term, you'd get 1,536. Here again, just like we did with the arithmetic sequences, the n is a part of our answer, n minus 1 is a part of our answer. The only thing we're plugging in for is the starting point and the common ratio. That's it, when we write the formula for the nth term. Are there any questions on coming up with that one? If you use an X instead of an asterisk for times, it's fine. Canvas might not like it, but I'll be okay. You just have to tell me. This is one where I don't want the formatting to be the reason you get this wrong, unless your answer is just wrong. It's possible your answer is just wrong. But if it's strictly a formatting issue and I can tell that it's just a formatting issue, like an X instead of an asterisk for multiplication, I'm going to make sure you get credit for. I want your grade to reflect your knowledge more than could you type it in right. So please don't. I want you to take it seriously, but I don't want you to worry about it, I guess, is what I'm getting at there. All right, find the next term for that one. I'll make a poll. Here again, a little bit of practice, making sure we're good with geometric sequences, making sure that we know what we're being asked for when we're being asked for the next term. We'll go another 10 seconds on this and then we'll talk about it. Almost unanimous. Very good. Okay. Oops. So the next term of this one, as we take a look at it, really all we're being asked for here when we're asked to find the next term is what would be next in the sequence. And we can see that this is multiplied by 3, multiplied by 3. Our common ratio here is 3, and it gives me a chance to use that word again. Because this has a common ratio, we're multiplying by the same thing to get to the next number. It's a geometric sequence, and we call that the common ratio. And so we're going to need to multiply by 3 to get to the next one. And sure enough, that's 162. Laura's question. Will there be questions that ask for us to write the formula and ask us to find the nth term? In general, I like the write the formula question better because finding the next term is a good practice thing because it gets you in the mindset of, is this arithmetic? Is this geometric? And am I finding the common ratio or the common difference correctly? But typically, these questions are awfully simple, so they don't make the best quiz and exam questions. Finding the formula for the nth term is a little more involved, a little higher level. I think those make better quiz and exam questions. And then using the formula to find the nth term, I'm pretty confident that if you can write the formula, that you'd be able to use it. So again, it's kind of that one right there in the middle of writing the formula is my favorite one to ask because I think that's kind of the highest level of understanding. Up next, you probably saw this coming. Find the formula for the nth term for the following sequence. Just as a reminder, formula for the nth term is a times r raised to the n minus 1 power. I want to give you a second to try to write the formula for the nth term for this sequence. Very good, Laura, Katrina, that's good. I don't think these are that easy to type, and you're doing perfect. You're doing beautifully. So our starting point here is A, and we saw on the previous that times 3 is our common ratio, so R is going to be 3. And we'll just plug those in. We have 6 times common ratio raised to the n minus 1 power, and that's our formula for the nth term. Very good, Sean, Brianna, excellent. Yeah, that's our formula for the nth term. We could find any term using that formula. If I wanted the 8th, I'd just put an 8 in here for n and simplify. Any questions on what we've done up to this point with arithmetic and geometric sequences? We are going to do some more practice later on, but if we're comfortable with this for now, I want to do something different for a few minutes. Okay. Find the missing term. What's going to go in that spot? Laura says 52. I don't know if we have agreement. I don't know if we have disagreement. Laura says 52. Oh, okay. Brianna and Sean agree. It could be unanimous here. As I look at this, let's see. That's plus 7. Okay, that's plus 7. Okay, that means this is an arithmetic sequence, which means we have a common difference. And so it's just going to be plus 7 to get here, and it'll be 52. And just to double check my work, plus 7 more would take me to the next one. So I feel great about my 52 being the next term, or being the missing term. And this is an arithmetic sequence that has a common difference. Let me know if you have questions on that before we look at another one. Oh, and as long as we have it here, I'm just going to go ahead and revisit. So for an arithmetic sequence, it's a plus n minus 1 times d. And so that's going to be n equals 31 plus n minus 1 times 7. And that would be our formula for the nth term. Just to practice that when we have the opportunity to. Let me know if there's anything on there that doesn't make sense or you're not sure where it came from. All right. Find the missing term. A little bit of a curveball in this one, a little bit different from what we've seen so far, but I think you'll be able to manage. Karina says 15. We don't have any agreement or disagreement yet. We'll see what comes up, and maybe that helps push you in the right direction. We'll see. Oh, okay. Sean and Laura agree. Aaliyah? All right, we got a whole bunch of 15s. That's good. Sergio, good. This can be a little challenging. Salia, great. Because the numbers are going down from left to right. We haven't seen this yet. Going down from left to right. Well, I don't even know what to do to get from 375 to 75. I mean, I guess you could subtract 300, but that's not going to work as I keep going to the right. So that it's definitely not subtract 300. So this is not an arithmetic sequence. It might be geometric, which means we multiply or divide by the same. Oh, we could divide. So what do we divide by to get from 375 to 75? I don't really know, but I can find out by just doing it. If I do 375 divided by 75, let's see, 375 divided by 75, that's 5. Okay, so if we divide by 5 here, that's what gets me from 375 to 75. So I had to do a little work here to find my common ratio and to find out that this is indeed a geometric sequence. Now, we haven't verified that yet, but if dividing by 5 is what we do, then I'll divide by 5 again, and that puts a 15 in here. And then to make sure it's right, divide by 5, it lands me at 3. Great. So now I'm confident in my 15. I'm confident that I have a common ratio, and this is a geometric sequence. A very reasonable question for you to have right now is, how would we write the formula for the nth term for this one? Because this is divide, not multiply. Great question. Here goes. We are still looking at a formula that's going to be a times r raised to the n minus 1 power. This is one where I can be a little bit forgiving as far as your typing goes. Because if this says multiply, but we're supposed to divide. Well, if you write this one as, let's see, 375 is where we start. If you write it as divided by common ratio of 5 raised to the n minus 1, I'm going to be okay with that. Technically, this is saying, well, I think you're okay here because of the exponent. Technically, you might want a second set of parentheses there, but I'm okay with that right there as the way you type this one in. Because we're going to raise to the power first, or we're going to do the parentheses first, we're going to raise to the power next, and we're going to divide last. So this works with order of operations. So, sorry about the colors. N equals 375 divided by 5 raised to the n minus 1 power. Because we're going to divide by 5, and divide by 5, and divide by 5, and divide by 5. That's we're going to do each step along the way. If you would rather write this with multiplication, and it's something we're going to talk about more later in the semester, but dividing by 5 is the same thing as multiplying by 1/5. You might remember that division is the same as multiplying by the reciprocal. I'm going to say that to you a lot later in the semester when we start talking about the 4 arithmetic operations, add, subtract, multiply, divide. But just for now, just maybe a refresher that dividing by 5 is the same as multiplying by 1/5. So if you wanted to write this with multiplication, You absolutely can. You could say n equals 375 times, I guess I want to do it in a straight line, 1/5 raised to the n minus 1 power. Either answer in those boxes is okay here. Either answer is okay. If you're going to do the 1/5, please put parentheses around it, because otherwise it looks like the 5 is getting raised to the power, not 1/5. So if you're going to do it that way, if you just want to write it as multiplication every time, that's great. Just make sure to put that 1/5 in parentheses. And again, I'll be pretty forgiving with your formatting on the quiz. What I'm mostly interested in is, did you recognize it's a geometric sequence? Did you identify the starting point? Did you know you're supposed to find the common ratio? And then how do you get from your starting point to the next term? And here that's either dividing by 5 raised to the n minus 1 or multiplying by 1/5 raised to the n minus 1. Oh yeah, Stephen, that's totally fine. As far as finding that 15 goes, you bet. That absolutely works. Yep. Yep. Very good. Okay. Does anybody have any questions about writing these? Either of those would be considered a correct answer here for finding the formula for the nth term for that particular sequence. It's important for us to talk about this because you will see somewhere the numbers get smaller from left to right, and I want you to know how to handle that rather than only seeing multiplication ones. Yes. Yes. We will keep it so that the numbers land. We will keep it so that your common ratio here is going to be a whole number, and so you won't see anything as a decimal. Technically, if you wrote this as 375 times 0.2 raised to the n minus 1, that wouldn't be wrong, but I sure do like the fraction way better. Okay, very good. Find the missing term. I don't think this one's necessarily easy, but I think some of you will get it. We'll see how it goes. You'd be allowed to call this a trick question at this point, but in 5 minutes when we're done with it, you can't. 37, okay. We'll see if we get some agreement here. Or, oh, all right, Katrina, we've got some agreement then with 37. All right, Brianna and Sean. Okay, I'm buying your 37 then. Let's take a look here. Let's see. 55 to 50. So that's minus 5. 40. Wait a minute. Minus. Okay, so this is not an arithmetic sequence. Maybe it's division then. If I do 55 divided by 50, 1.1. If I divide by 1.1 each time, boy, that feels clumsy. 50 divided by 1.1, yeah, that's not 44, so that doesn't work. So that's no good either. What this one is, we've looked at arithmetic sequences, we've looked at geometric sequences. This is neither. We don't have a common ratio. We don't have a common difference. This is neither. We're just looking for any kind of other pattern that might work. And here we're subtracting 5, subtracting 6. Hey, maybe we subtract 7 to get 37. And then if we did that, we would subtract 8 and it works. So sure enough, 37 is our missing term there. Great work by those of you that came up with it. I don't think that's easy to see, especially because we've been hammering arithmetic, geometric, arithmetic, arithmetic, geometric. And then here's this one that's neither of those. 3 types of sequences that we'll look at. Arithmetic, that have a common difference, geometric, that have a common ratio, and neither. We're not going to write a formula for the nth term for neither. We're only going to write the formula for the nth term for arithmetic and geometric. These will not be a primary focus for us. I just want you to know that they exist and that not every sequence is arithmetic or geometric. Okay, let's do some practice. And I won't set up a poll because typing it's kind of clumsy. I'm just going to kind of step back and let this breathe for a minute and give you a chance to decide whether this is arithmetic, geometric, or neither. And then, if possible, find the formula for the nth term. Actually, I'll do a poll. Hold on. Oh, Laura's way ahead of me. Okay, we got some neithers and 12s. We'll do that. Going forward, I'll make a poll with arithmetic, geometric, or neither. But for this one, we'll just kind of roll with it. All right, we're getting some 12s and neithers in there on this one. All right, let's see. See if I buy that 12. Let's see, 2 to 3. Well, that'd be plus 1, and this is plus 2, and that's plus 3. So plus 4 seems awfully reasonable to get us to 12. I can see that being legit. Anybody else see something different in here that might also be a correct answer? I'm good with 12 as a correct answer here, and I'm good with neither as our answer. Is there something else that might be a way to look at this one and get a different answer for that instead of 12? And it's perfectly fine if you didn't. What I'm getting at is we're going back to the very first day of class where you might not necessarily do it the exact same way as somebody sitting next to you, but as long as it's valid, it's okay. Because there's another way to have a correct answer here. I really like 12 as an answer, and I like where Brianna's going. What would you end up with for your next term? 13. All right. So let's see what Brianna did here. She said, well, if you take this 2 and 3 and add them together, you get 5. And if you take the 3 and 5 and add them together, you get 8. So I'm going to take the 5 and 8 and add them together to get 13. And I think that's totally valid. You'll notice that this question up here just said, is it arithmetic, geometric, or neither? We're all in agreement that it's neither. The next term, well, it kind of depends. There's two different patterns going on here within the same series of numbers. So I wouldn't ask you for one where it would be ambiguous. Our answer here is just, this is neither. It's not arithmetic and it's not geometric. Very good, Brianna. That's excellent. That's hard to see. Okay. I'm going to ask you arithmetic, geometric, or neither, and then you take a minute and try to find the formula for the nth term if you can. All right, so there's a poll for the arithmetic, geometric, or neither part. And then once you've decided if it's possible to find a formula for the nth term, take a couple of minutes and try to do that. And I'll just wait until you've had a chance to come up with the formula for the nth term, if there is one, before I look at the poll results. All right, let's go another 10 seconds, and then we'll look at the poll results, and then we'll talk through the formula for the nth term if there is one. Okay, not unanimous, but close. That's very good. Very good. If there's anything that isn't making sense or you're not sure of when we talk through it, just make sure you ask. So is this arithmetic, geometric, or neither? Well, let's see here. Um, that looks like -4, and that looks like -4. So we're subtracting 4 each time. So this is going to be an arithmetic sequence where we have a common difference. And once we know that, we're going to find the formula for the nth term. And for a arithmetic sequence, that's going to be n equals a plus n minus 1 times d. And we know here that a is 51 and our common difference is -4. There's two ways you can write this, and it's perfectly fine either way. One way is to go n equals 51, the starting point, plus n minus 1 times d, which is our common difference, of -4. That's how we handle the fact that it's going down as we go left to right, is our common difference is negative. It's also perfectly fine if it just makes more logical sense for you to write it this way, that n equals 51 minus n minus 1 times 4. That instead of adding a -4 each time, we are going to subtract 4 each time. Either of these is perfectly fine for this answer. Any questions on that one before we look at the next one? Very good. I get a sense we're doing pretty well here. Um, Same as last time. I'll make a poll for arithmetic, geometric, or neither. And then if it has a formula for the nth term, if we can write one, then we'll do that. We'll go another 15 seconds on the poll, and then we'll talk through the results here on which one of these is it, and if it's arithmetic or geometric, what does the formula look like? All right, very strong geometric, not unanimous. If you have questions, please don't hesitate to ask them. I get a sense that a lot of people are doing really well and are very comfortable with this, which is great. But if you have questions, please don't be shy about asking them. The beauty of having a class meeting is you get to ask things now instead of when you're working on homework, and and it's, you can email, of course, you can post on a discussion board, of course, but right now is a great time to ask those questions that you're having if you're having them. All right, arithmetic, geometric, or neither. Well, the way we decide that is, let's see, 8 to 40. That's I could do plus 32, but that's not going to work over here, so it's not arithmetic. But we can multiply by 5 and multiply by 5, and sure enough, this is geometric. Once we know that it's geometric, our formula for the nth term is going to be a times r raised to the n minus 1 power. Okay, well, here we have, let's see, our starting point is 8. N's going to stay a part of our answer. Our starting point is 8. Our common ratio is 5, and we're going to raise that to the n minus 1 power. This one's a pretty straightforward answer. 8 times 5 raised to the n minus 1 power. Great, Brianna, Joanna, excellent. Oh yeah, Katrina, Aaliyah. Wow, there's a bunch of them in there. I didn't see those because they were before I put the poll up. Very good, very good. It looks like we're doing great. Fantastic. All right, let's look at another one. Arithmetic, geometric, or neither? And if it's arithmetic or geometric, find the formula for the nth term. I'll do a poll again. We'll do another 10 seconds on this, and then we'll talk through it. See how we did on this one. All right, unanimous. Very good. All right. We definitely recognize that this one is geometric. And when we take a look at it, the way that we recognize that is by seeing that, okay, when I go from one term to the next, well, minus 600 is not going to work, so it's not arithmetic. But we could be dividing by 4 here, and sure enough, dividing by 4 works for the next one. So this is geometric. We have a common ratio of divide by 4. Formula for the nth term for a geometric sequence is going to be a times r raised to the n minus 1. Make sure that n minus 1's in parentheses. I'll be pretty forgiving about the rest of it, but make sure that n minus 1's in parentheses. And here our starting point, let's see, our nth term is going to be our starting point, and we're dividing by 4. So you could write it as divided by 4 raised to the n minus 1, and that's okay. You could also write it as 800 multiplied by 1/4 raised to the n minus 1. Either one of those is just fine here. Let's see what you guys have typed in over there. 800 times 1/4, 800 times 1/4. All right. Divided by, which is perfectly fine, Katrina. You're good there. Christopher, you too. Yes, Austin. Both of those are acceptable on quizzes. And if you put a space in, Canvas isn't going to like it. That kind of thing. If it happens, please don't panic. Please don't get mad or worried. Just send me an email and say, I'm pretty sure my formula for the nth term is correct. Can you take a look at it for me? So don't get mad. Just email me. As long as you're correct, you'll get credit for it. If it's incorrect, then you won't, but I'll tell you why. But if it's strictly a formatting thing, I'm going to be pretty forgiving because I realize that these aren't the easiest things in the world to type. It's not like we've had in the past where how many buses do you need? 12. That's